We're talking about the 95% confidence level, and we were saying that it basically represents the variation when we go take repeated samples like what we were discussing. So I hope that is clear. You know that. Now let's talk about the 5% trimmed mean. The 5% trimmed mean. You realize that there's a difference of the mean and the 5% trimmed mean. Now the trimmed mean, this is a mean of the variable when the top and the bottom 5% of the scores have been excluded from the computation. Suppose we have values. Now we exclude some cases. And these cases that are excluded are 5% of the top and 5% of the bottom. Now that mean of those values, excluding the 5% bottom and top, is what we call 5% trimmed mean. Now, this trimmed mean removes relatively extreme scores from both ends of the distribution. It removes the very low values and the very high values. Now, when the trimmed mean and the mean, or that is the average, the mean itself differs, it is a very rough way to determine that there could be outliers in the end of the distribution. Outliers are like abnormal observations in the distribution. So the 5% trimmed mean is that mean when 5% of the variables from the bottom and the top are excluded. And it is very useful. I want us to look at this case. Look at this case here. Let me just try to do a simple math. Suppose we have these values. Let's see. Let me open a Word document and maybe so have some values. If that will take us much time to demonstrate the 5% mean. Now, suppose we have some values, some observations rather. We have some observations. Let's say we have these observations. We have maybe, let's say 10, 20, 30, and 40. Now these are our observations. So suppose we want to get the mean of that. Remember these are 4 observations. 1, 2, 3, 4. There are 4. So if we are to get the mean, very fast, what is the mean there? What is the mean, guys? Mathematicians. Is the mean not 20? Guys, the mean... Sorry? It is?
25.
Oh yeah, you guys are not sleeping. It's 25. Now, you realize that is the mean. The mean is 25. Now, assuming the last observation is 100. Now we have a new observation 100. So what is the mean now? What will be the mean? Even if it's not exact but approximation. The mean will be something like
40.
Sorry?
40.
Okay, Morrison, okay, someone is saying it's 40. Let's say the mean is now 40. So you realize previously, when we were having these two, alone, these two values, when we are having these two values alone here, the mean was 25. But now that we are having these two values of, these 5 values of included another variable, another value, we have the mean as 40. Now, when you look at this data set, which one looks like to be like showing how the data is well distributed and all that? You realize actually from this, the values are kind of the same range. And they are reasonable to have the mean 25. But now when you look at these variable values here, you realize that the mean is very high to 40 because of only one variable, there is 100. Because actually, all other values except 40, when we remove 100, of course, you realize that they are less than 40. So actually, this mean doesn't make any sense. It is abnormal high. Look at 25. You realize all these values are reasonable because 25 sits at the middle here. 25 sits at the middle here. We don't have very high values and very low values. Actually, we have 2 low values and 2 high values above the mean. So it is making a lot of sense. It is very symmetric in this data set. But look at the mean here. The mean is just because we have a very high value, making it to skyrocket to 40. So this observation 100 is abnormal high. Now, what 5% mean does is like this case. The 5% mean, the 5% trimmed mean is like, if these values, we count these observations, then we compute 5%. But that is the number. Like this 1, 2, 3, 4, 5. So it will be 5 over 100 multiplied by 5. Of course, maybe it is, let's say we are getting 2 because the data set will be very high. Several cases. So which means we'll remove 2 observations at the bottom and 2 observations at the top. We are trimming. So in that case, we'll now remove this variable. Maybe we are removing this variable at the bottom and we are removing this variable at the top. Or maybe we had 5. So at the end of the day, we have only these variables remaining. Now when we compute our mean now will go back to 25 because we have trimmed what was abnormal high. We had trimmed what is abnormal high from the bottom, from the top. So that is what the 25% mean does. So basically, when the mean and the mean itself and the 5% mean differs, it could suggest an outlier, like a value that is abnormal high or abnormal low. And look at this case. That is very true. But now we are saying that using the 5% trimmed mean to determine the outlier is a rough idea. It is not actually the best approach. There are several other approaches that we can use, and I will be able to see that. Now, let's come back. We are done with the 5% trimmed mean. Of course, we've talked about median several times, the variance, the standard deviation, the maximum and the minimum, the range. Of course, the difference of the maximum and the minimum. Talked about that when we were doing advanced Excel. Now the interquartile range. The interquartile range, also known as IQR. It will always be abbreviated like that. The interquartile range, IQR, is the absolute difference. The absolute difference between the scores corresponding to the first quartile and the third quartile. That is the interquartile range. Remember, range is the difference. Now, interquartile, it is a difference of the quartiles. Now, it is now the 75th percentile minus the 25th percentile. That is the 3 over 4 quartile. That is minus the value we obtained minus the 1 over 4. So that is the difference between the corresponding first and the third percentiles. That is the interquartile range. That is the interquartile range. Again, of course, we have talked about the skewness and the kurtosis. We have talked about the skewness and the kurtosis. So there is not much to talk about the skewness and the kurtosis. Now you realize, okay, depending with the version of SPSS we are using, something was supposed to be displayed here, but it is not displayed. We have we were supposed to have another table. This table was to be designed in a certain way, but don't worry, I didn't include that. I didn't include that. But let's go to the chart, the histogram. The histogram. Now this histogram basically shows the distribution of the variables in terms of the frequencies, like the age now, between 0 and 20, between 20 and 30. You can see the bars and all that. And actually, we have very high, very many and high low values than the high values in terms of age. So it is asymmetric, not symmetric actually. Now there is the histogram, but most importantly is the box plot. This one is called the box plot. Now we're going to talk about the box plot, and the reason as to why I was saying there's something that I didn't include. Maybe let me just check that if I can include it, it will be better. Just a minute. Okay, it depends whether it's just a version of Excel or is it still okay? SPSS, not Excel. Now, you realize on this box plot, it's very important to talk about. Let's finish by talking about this. You realize what I was trying to look at is there's I'm running version 26 of SPSS as well. Now you realize it will give us the percentiles output in a table, so that the table is divided into two. We have the percentiles and the quartiles. We have the percentiles listed. It is only giving us the range, but there's a way. With the other version, the explore method, they'll give us all the percentiles listed like that, and then the quartiles at the far end. You see, the quartiles are very important when we are computing, or rather, in terms of generating the box plot and talking about it. Now, let's just talk about the box plot. Now you realize there's this rectangle box here, you can see the rectangle, or rather the box. Now you realize this box here, you can see the rectangle box, actually is called BossWhisker, not whiskey. It is called a BossWhisker, and the reason why it's called BossWhisker, the box is from this rectangle you are seeing here. Now the rectangle is approximate the center of each box, represents the median portion. The middle portion of the distribution. You see there's this line which is approximately at the center, even though it's not at the center in this case, but it will normally be approximately at the center, and it represents the middle portion of the distribution. The median, that is the 50th percentile, is marked by this heavy horizontal line. So this horizontal line here that you can see represents the median. That is the 5th percentile. Remember, percent means over 100. So when we take 50 divided by 100, that is a half. So this is where the median will be. That is where the median will be. It is represented by this heavy horizontal line. Now the lower and the upper boundary of the rectangle are approximately the first and the third quartiles. This here, the lower and the upper bound of the rectangle. So this you are seeing here, this bound, the upper bound, represent the third quartile, and the lower bound of the rectangle represent the first quartile. This is the third quartile, and this is the first quartile. Now you realize that we have now three: the 5th percentile, the third quartile, and the first quartile at the bottom. So those are the 3 percentiles that will be computed, and they will be demonstrated by the box plot. So this box plot, the rectangle, the horizontal line is the median, the upper boundary of the of the rectangle that represents the box is the third quartile, and the middle boundary is the first quartile. Now you realize there is a vertical line that is extending from the box. You can see the vertical line that is extending from the rectangle, or rather the box, at the top and the bottom. Now these are what we call the whiskers. They are what we call the whiskers. They are the whiskers. Hence now the name box and whisker plot. Box and whisker plot. Because this is the box, the rectangle is the box, and now these are horizontal line, the vertical line that are extending are called the whiskers. That's the name box and whisker plot. It is called the box and whisker plot. Now, their end, the whiskers, the end, you see there's a line at the end, at the upper and the lower. So their ends at the lower and the upper are what we call the upper and the inner fence, respectively. So this is the upper fence and this is the lower fence. The upper inner fence and the lower inner fence, they are very important. The upper inner fence and the lower inner fence, they are very important, more so when it comes to identifying outliers. Now, I'll just say that outliers are like abnormal observations. Now you realize that these fences, that is the upper inner fence and the lower inner fence, are drawn a distance of plus or minus 1.5 of the interquartile range. Of the interquartile range. There are plus or minus 1.5 of the interquartile range. What am I saying? You realize here we have the interquartile range. The difference of the upper and the lower quartile range is 7. Now you realize we said that this one here is the third quartile. Now this whisker here is a plus of 1.5 of this upper quartile, the third quartile, this whisker here. It just extends by a plus of 1.5 of the interquartile range. Now this one here is also a plus, a minus now 1.5 of the interquartile range. Now, what these are upper inner fence and lower inner fence are used is to determine the possibility of outliers, those values that are abnormal high or abnormal low. You can see that the data points that exceed the 1.5, that is the plus or minus. I'm saying plus or minus because they could, at the top there is now a plus and at the bottom there is now a minus. So data points exceeding a plus or minus 1.5 of the interquartile range, but now they are less than a plus or minus 3. They are above this, because they are above 1.5. We said this is an extension of 1.5. So they are above this. That is now they are above 1.5. But now again they are less than 3. So they are up here but they are less than 3. So the distance from here to that point is less than 1.5 again. So they are less than 3. Are designed by a circle. You can see these values have a circle. So all these values that are designed by a circle, they mean that they are actually above 1.5 of the interquartile range, but again they are low than 3. They are lower than 3 of the interquartile range. So they are having a circle. They are having a circle. Now the data points that exceed now 3 of the interquartile range. Now IBM SPSS will represent them with a letter E or asterisk. You can see these values have a asterisk. So all these values that have a asterisk are actually plus 3 more than the interquartile range. And these values that have circles are plus 1.5 but less than 3. But less than 3. Now you realize actually IBM SPSS, I was telling you the other day when we were doing Excel and we were looking at the anomalies. These are actually anomalies. They are anomalies, abnormal observations. We were not actually given a number. You see, SPSS is giving us even more information. Those values that are more than 1.5 but less than 3 are shown by a circle. So we can distinguish already from these outliers and these outliers. Now this one having a star because they are greater than 3. Now again realize there is a number. Like this one is 400, this is 269. Now this is the number of that particular observation. So you can simply come to the data set and look for the observation 400, the observation, this is the number of observation. So the observation 400 is actually an outlier. So you can scroll down to that observation 400 and look what is the edge and realize it is 75. Actually 75 is abnormal high from the rest, because roughly looking at these values here, the value is actually 59 is the highest here in this case. So 75 is kind of abnormal high. So that value you are seeing there on that dot is actually the observation, the position of that observation. It is a number in terms of observation. So what IBM SPSS is trying to tell us is to show us the level of seriousness of that outlier, how serious it is. Like these one that are indicated by a circle, they are above the interquartile range by 1.5. So still we might consider them in our analysis and they won't have a serious problem in doing our analysis. But what about these that have a star? These one are now serious outliers and we need to take care of them whenever we are doing analysis. So that is one way, or that is the beauty of using the explore method when it comes to descriptive analysis. It gives us more additional information than the descriptive approach or the frequency approach. But again, it is important to take note that this method of descriptive analysis is only applicable to quantitative variable, that is continuous variable. So we cannot do it for a categorical variable. I hope you guys understand now the three methods of descriptive analysis. That is the explore, the descriptive, and the frequency. Any question up that point? Any point that is not clear? Any concern? Kindly ask. Hello? Lawrence, are you still there? Yes, Elvis, your microphone was unmuted. Any question? Well, if there's no question, then I think we can stop there for today. That was our descriptive analysis. Explore, frequency, and all that. I will not cover cross tabs because it is very fundamental. Here is a case where now you want to customize your output. Maybe you want to generate a table. It is very simple. So long as you know those two, you can actually use it. But don't worry about this, because at one point we'll use it in our influential analysis for the course of chi-square test and all that. So I think we can stop there. If you guys have no question, I'll give you an assignment tomorrow that covers almost everything from data entry, how you enter your data into SPSS, covering everything, every aspect, data manipulation, that is merging, selecting cases, all that, splitting and all that, as well as saving your output and all that. So, guys, I think it's enough for today. So, unless you have a question, otherwise, good night.